Hello there, and welcome back for more Advent of Code 2022. So today it was the 6th of December, but now it's the 7th because it's past midnight. And to be honest, I have been falling a bit behind. The last couple of days I didn't complete the puzzles. Like I think on Sunday and Monday I was a bit busy and I really couldn't get back to this. But well, hopefully today we can continue where we left on. By the way, let me show you something that I have been working on the project at Advent of Code 2022. Let's open it. So I have done a bit of refactoring over the main function. So now it's it's longer, more complex. Before it just executed the three daily puzzles that we had, but now it does a bit more. Like if I do cargo run, well, it still executes each day. Now it also prints which day it is, but now it can also receive like a single day to just execute that. And well, I have tried to make it a bit more explicit on the error handling. There's probably a lot to be improved here. But generally I like the shape of this a bit more and what it does. I also extracted, like from each single day solution, I extracted everything that has to do with I/O. So the reading of the input file doesn't happen here anymore. It just receives the input as a parameter. And it doesn't even do the printing of the answers. Instead, it returns both answers to both parts of the daily puzzle as a tuple, and then in the main function is this one that takes care of reading the file and handling any errors about that here, and also getting back the functions, the answer, sorry, and then printing them back. And generally I went for a very like explicit error handling approach here, where if anything goes wrongly, something is printed to standard output. So for instance, if I call this with an invalid number, it just says invalidate number, instead of like doing an unwrap over the parse here. I'm actually like handling the non-OK case explicitly, and in general I like this. I like the result of this approach. It's a bit verbose, and sometimes I'm doing things which I suspect are not very idiomatic in Rust. But well, I still probably have to learn a few things about error handling. And yeah, that's what I've been up to. I think I did these changes earlier on today, but well, I didn't really like the take on that video, so I'm probably not going to publish that. I just found this a lot and couldn't make it very, very focused. But okay, let's jump back into the actual puzzles and see what puzzle number 4 is. So day number 4 is camp cleanup. Okay, so let's bump the font size. Today I had some medical examination, so I'm still seeing a bit blurry, but I think I can read all right. And by the way, I'm drinking tea instead of mate because it's quite late and I don't want to drink so much caffeine. So camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned to the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. Okay. However, as some of the elves compare their section assignments with each other, they have noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, your puzzle input. For example, consider the following list of section assignment pairs. Okay, so the input is formatted like this. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2, 4, sections 2, 3, and 4. Okay, these are ranges of contiguous section ID numbers. While the second elf was assigned sections 6, 8, 6, 7, 8. The elves in the second pair were assigned 2 sections. Okay, the elves in the third pair 2 sections. Yes, each of these has 2 sections. And the third pair were assigned 3 sections. One got 5, 6, 7, while the other got 7 plus 8 and 9. Okay. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. Okay. Let's actually open the puzzle input to see what are big numbers. Okay, so it seems like they are 2-digit numbers. Yeah. Okay. Fine. Where were we? Yes, okay, visually it looks like this. Fine. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2, 8 fully contains 3, 7, and 6, 6 is fully contained by 4, 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So this seems like the most in need of reconsideration. In this example, there are 2 such pairs. Okay, so I guess this one and this one. In how many assignment pairs does one range fully contain the other? Okay, so we have to check for like full overlaps. Okay, let's copy the sample code. Let's create a new file here and let's call it day4. And before anything else, let's start using it, because otherwise the language server doesn't want to do like error reporting or anything on that file. And well, as you can see, upon my refactor of this main thing, there now exists like a static array of, not static, but an array, fixed array of the day functions. And so this array is iterated here when we, or well, this is the function that runs a single day. But the array is also iterated here to like run each of these days. Anyway, or if you want to run a single day, like that day is taken from that array too. Okay, let's do a public function run that will take an input as a string slice and will return a tuple. So far, it's been all the examples have been okay to use U32s, like 32-bit integers. I hope that this assumption is not bogus, but maybe it will at some point. We shall see. And then we have day4 txt. But anyway, imagine if I haven't created this, just to showcase the error handling. Now if I run this, it fails with a nice error. Well, yes, actually it fails with error reading input day4 txt, no such file or directory. So I can, like, this is a better error message than the unwrap that we were doing before that didn't even tell us like which file was missing. So yeah, I quite enjoyed doing that refactoring of the error handling on main. So okay, we now have the inputs and we have this, so it should run without problems, but of course the answers are not that. So how many elves are fully overlapping? Well, let's do I wonder if I should start doing like parse the input first and then process this thing. I'm pretty sure that's going to be probably needed in the second part, but let's not get ahead of ourselves and just do the simple thing. Let's get each of these lines, and then what do we want to do actually for each of these lines? We want to like count how many of them have a fully overlapping thing. So count, well, it just returns a U size. That's not what I want. I probably want to like filter and then count. And this is going to be how many assignment pairs does fully overlapping pairs, yeah, or pair count could be fully overlapping pairs. And this, okay, so we already have a problem here if it counts, of course, returns a U size, and we're having U32s. So for now, let's just cast this as U32. And how do we want to filter these lines? So I guess we're going to need to do some parsing. So first, let's start by splitting. There was a function for strings that was like split once, yeah, which is pretty nifty. We can do split once by commas. I think it was commas, yes. And come on, if we do this, what, I don't remember if we get like a tuple or what. Yes, an option of a tuple. So this will be like the first elf sections. Well, range, I guess. And second elf range, I think. And of course we need to unwrap, or at least expect this thing. Line should be a comma separated range, pair of ranges. Why don't you like this? Expects a bool, of course. I wonder though, can we like map this thing? Because now we need to like map each of these to then also split them and parse like the numbers. So, well, I don't know. Oh, I'm noticing this thing. Indent using spaces, detect indentation from content. Come on, why don't you do that on your own? It's very annoying to have all squiggly lines there. So it would be nice if this thing split once would return like a static array instead of a tuple, because these things are of the same type, and then we would be able to map them. But okay, let's do first the range, parse range or something like that, and of course take advantage of Rust allowing to redefine variables. Second, the range, and parse range is going to take a string as string reference, and it's going to return, well, a pair of, which can be a tuple. Of what? Of, I guess, U32 could be. Why not? So this thing will have start end. It's going to be, again, same idea as before, split once, but now the delimiter is going to be a slash, I think, no, hyphen. How is this thing called? Hyphen, right? And we're going to expect ranges should be it's not hyphen. How is this thing called? Man, I'm having like a brain fart. Hyphen, yes. But isn't there a more common name for this? Dash. Well, yeah, minus sign. Well, should be hyphen separated numbers. Should have a hyphen. Okay, and then we can do just return this thing. Start parse and end parse, and of course, should we again, like, it would be nice to have these two like in an array, and then like static array, and then just map with this. That would be pretty nifty. Don't bother snap store. So Rust tuple to array. I don't know if there's like a convenient way of doing this. Convert into. Wow, it's implementing some trait. Yeah, I mean, yeah, so tuples are like heterogeneous data structures, so I don't know why this split once is done this way. Seems a bit silly, because then you cannot treat these things like as homogeneous values. Let's do unwrap and unwrap, and don't think about it too much. So why are you complaining? Well, oh, it's expecting this. Okay, so actually we have all the numbers that we need now, right? Yeah, I think so. So maybe we can have like elf1 start, elf1 end, something like this, and then have the same but for the second elf, and then we just see if they overlap. So when do they overlap? I guess one will be fully contained. How do we express this? Well, let's consider the case where elf1 sections are fully contained within the elf2. So this would mean that the elf1 start is greater or equal to elf2 start, and that the elf1 end is less or equal to the elf2 end. So it starts after it starts after and it ends before. So that's good. That would mean that the first elf is fully contained within the second. And now we can do the same, but basically turn these things around. If the second one is contained within the first. Of course, there's probably going to be a much better way of doing this, but let's run this now. Okay, so we actually have the answer 2, which is what the answer should be for this sample input. So let's put the actual input here and rerun. 498. Let's submit that and try it out. And yeah, nice. First part done. Let's see what part 2 has for us. I wonder how many things are invalidated. How many assumptions, I mean. Okay, it's a short part 2. It seems like there's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs, 2, 4, 6, 8, and 2, 3, 4, 5 don't overlap, while the remaining 4 pairs do overlap. Okay, it tells us how overlapping is calculated. It's not too difficult to understand, like 5 to 7 and 7, 9 overlapping 7, 2 to 8 and 3 to 7 overlap in sections 3 through 7. So in this example, the number of overlapping assignment pairs is 4. How many assignment pairs do the ranges overlap? So, okay. I guess we could what should we do? This is the count for fully overlapping pairs. I guess we're going to do something very, very similar for the other one. And like, I would even go so far as to say, I want to make this a mutable thing. Start it at 0. And then just do a simple for loop here instead. For line in input lines, we're gonna do what this thing has here. Remove this, and then we're gonna ask if this is true. Then we're going to increment the fully overlapping pairs by 1. And now let's implement, well, let's first check that this has the same number. Yes, it does. And now let's do the other condition, which is if there is some overlap. How do we check for some overlap? Let's do it in an ugly way first, like we did before, and then we can think of a better way. So there will be some overlap. For instance, how do we check this? There's surely a very simple way of checking this. So basically, for instance, if the first elf starts, is before or equal to the second elf end, and what? Because it could be before but not overlap. Basically, if it is within, right? Yeah, if it is like greater than the start, and less than the end, then we already know that, like, if either the start of end or end is within the there should be, I'm overcomplicating this. There surely is like a very simple way of expressing this, because it is basically like collision detection or something like that. So let me think. So in order to have some overlap, it doesn't need to be how do we can actually like make the numbers and see like the overlapping set or something like that, and if it is present at all. I mean, that wouldn't be too bad either. Like if there is some repeated number, like we did for, I think it was day 3 or something like that. So yeah, the fully overlapping, if I express something similar to that, is going to be it's gonna be a bit stupid, I think. So how do we calculate this? Come on, let's think. When do they not overlap? Maybe I could think of that. When will they not overlap? Well, they won't overlap if the first one ends before. Let's just think of not overlapping and maybe then invert it. If the first one ends before the second one starts, then they surely are, like, that's the condition for not overlapping. Or if the elf1 starts after the elf2 end. In that case, we know that they are not overlapping. So if we say not this, then they should be overlapping. So okay, this is not overlapping, like the first one doesn't overlap the second one, right? And is this does this also apply the other way around? Like if the elf2 start is greater than the elf1 end, that also means like elf2 is not overlapping with the elf1. So I think this is actually what I want, right? We negate this and say, well, let's add another variable to keep track of fully overlapping pairs and how do we call this? Like semi-overlapping? Well, overlapping pairs, let's say. This is not overlap, and we mapping pairs plus equals 1. And I am a bit oh, we don't need to cast this, I think, now. Yeah, overlapping pairs, and I'm almost hesitant to do it with the actual input. Let's run it like this. Okay, it gave 4, which was the answer for the sample input. Let's do it with the full input now. 859. Cool. Submit. Yeah. Cool. I cannot say that I fully understood what I did here, but I like it that the some overlapping expression is a bit simpler than the fully overlapping one. That at least feels good. So this is nice. This one is nice. This one not so much. I think we can also simplify this by saying this should be, I think, equivalent to saying let's say this, and like inverting everything basically. And now with just, I did it mechanically and still gives this same answer. Cool, we don't need the parentheses now. So if the elf1 end is greater than or equal to the elf2 start, what does that mean? So it ends after the elf2 starts. Yes, that's cool. And it also starts before the second one ends. So okay, it ends after the second one is starting. So that's or equal. Like it might end when the other one starts. But if it ends after, like if it's not overlapping and it's ending after, they will be overlapping if the first one starts before the second one ends. Okay, so this expression, yes, it is logically it means the same as the other one, but it also makes sense in my head. So that's very nice. And of course, with the error handling that we have, we can do things like this, I guess, and have some. Yeah, line should be a comma-separated pair of ranges. Nice, nice error handling. So, okay, we have actually the two answers already. That's pretty good, I think. I mean, this solution is doing some ugly things about. I mean, I'm not in love with this expression. Maybe we could simplify it. So this means fully contained. I mean, if we could have like an expression to say how much they overlap, like, and give me a number, that could be useful. Because like if that number, for instance, is greater than 0, we could increment this, and if it's the same as the length of one of the elves, we can also say this. But is okay. This means elf1 is fully contained within elf2 sections, and this means elf2 is fully contained within elf1 sections. I'm okay with this, I think. Yes, let's add this. Sure thing. I was thinking of, can we do the parsing a bit easier? Could we do it? Because I tried to use split once, because it knows like the size of the thing that you want to get returned. Whereas if you use just split, I was thinking maybe we could split by hyphens and commas, like either one, and just get the 4 numbers out of this. That would be kind of nifty, but I think that that's not very easy to express in Rust, I think. because like you cannot say, hey, I expect this to be an array of size 4, or to easily cast a vector, a dynamic vector, into an array, at least that I know of. So for now, yeah. For now, this seems good enough for me. I'm just checking what I wrote. Maybe it's a bit verbose, but I'm okay with that. Fully overlapping pairs and overlapping pairs. Nice, and we give these two answers. That's pretty nice. We can commit. Maybe we can write something in the README about today's challenge. Say day 4. This is, and it was camp cleaning or something like that. Camp cleanup. So did I learn something, or do I have something of note? Not much really. Well, let's say this was a simple. This one was a simple logic, overlapping logic pasta. Yeah, a nice breather before harder things to come, for sure. Okay, that's nice. Let's also add this, and let's commit. Day 4 solution. All right, I am still wondering if there is. Let's try to very quickly to see if we could do splitting in a more in a better way. Iterator behavior, blah blah. Connect. So we could, for instance, split. I think the pattern in which you can split. You can also have like a function to split on, or yes, and this is the other thing that I wanted, like a tuple of. Why is it doing this? I don't know. Well, let's say if we split by dashes and commas. No, dash is not the, or is it dash? Yeah, maybe that's the, yeah, dash. It was the word I was looking for, not hyphen. But I mean, hyphen does sound a bit more fancier, so I will keep that. Numbers. So what if we have this? We split by this, and we map by well, let's do as parse and unwrap for now, and finally collect, and this shall be a vec of u32. Let's see. This actually does work. Let's print this out. Numbers, and let's go here and do this to have a simpler example. Cargo run number 4. Okay, I think this also does work. At least parsing the numbers like this is much simpler. So that's preferable. That is preferable. Now, is there some simple way to destructure this into like a static array? Because that would be nice. Like saying something like f1 start and end to be like numbers. Like it doesn't like this. Consider slicing. We could slice. Yes, maybe that works. So if we slice this, say like this, does this work? Why? Not chords. Refutable pattern in local bindings. So yes, okay, this is not covering everything. Yeah, but we could do something like let's do this f1 start, f2 blah, this two. Do I have suggestions? If this is prefix underscores with no, I don't want that. But we could do what do you suggest? Yeah, this is not correct, but let's so I guess we could do a let else here. So we have these things, and else we are going to just panic. Yeah, and now we don't need to. Well, line should be a comma separated pair of ranges. The message can be similar here. And unwrap. I guess we can say that we expect section IDs should be numbers. Invalid line format. In this case, like if we have less than 3 numbers, we can say invalid line formats for and we can even print the line. Yes, how about this now? Well, it crashed. Invalid line format in here. That doesn't seem correct. Okay, yes, because we need to actually extract the things correctly. Let's say 1 till 4, right? 0 to 4, sorry. Nice. And if we go back to the full input, yes, nice. Okay, I did learn something new today then. It's not so bad to parse things this way, like extracting all the numbers that I want, collecting into some dynamic data structure, and then like pattern matching against like a slice of that data structure. Okay, so here maybe this this thing might not be catching like lines with more numbers because we are only extracting like the first 4, I guess. We cannot say this though. Oh no, I guess we could just do this kind of slicing. Yeah, we don't need to hard code the numbers. That's even better. Yeah. Damn it, I really like this now. This is really cool. And I actually did learn something new. Well, the comment is still true, but learned that collecting, how could I say, like that using splits, string split, and collecting the results into a dynamic vec, and then pattern matching a full slice of that array into variables is a very nifty way, a very convenient. The way of parsing some of these challenges or puzzles. Cool. Well, two slightly smiling faces is maybe a bit too much, so nice period for harder things to come for sure. Let's end that sentence with periods instead of a smiley face, so now it sounds more ominous. Yeah. Okay, so I like this much better than we have. We can still we can check what we did here. So this is pretty good. Let's add this and commit. Improve parsing logic for day 4. And yeah, let's push these changes. And I'm pretty happy with the solution for day 2. So this will be the end of this video. So if you have been watching, thank you very much for doing so, and see you later. Bye.